Okay. It's 1:30. Let's start. Okay, here's a topic today, but I figured last time was a little bit rushing. So I guess a few of you kind of understood what decision tree is in terms of formulas and computation, but as a big picture and how it's really working, I don't think it's clicking in for you yet. So I will give a review today so that you at least see the overview of decision tree classifier, okay? And then we will talk about the parameter tuning, because that's also one critical step in classification. All right, first an announcement, okay? This is important. First of all, about the proposal that you submitted, I think 2 weeks ago or so. So I have already downloaded all your reports and I started reading them already. So next week, we will, after the lecture, during the lab session, I will meet each group one by one, okay? I think we have plenty of time for that. So during the meeting, I will kind of talk to you about the details that you put in the proposal, just to discuss if it's really if it makes sense to do as a group in terms of scope and everything, just to get to know more about your project better. Yeah, that's all. So make sure next week, everyone in the group should show up, okay? All right, that's the first announcement. Second, for the collab or other platforms that you'll be using during the exam today, make sure that you disable all the AI related equipped features, okay? Well, for collab, I know for sure that there is this thing. So after you run some cells, which will print out a table, okay? You run data frame and it will display the table. Then it will have this little thingy showing right in the bottom, basically recommending, show any recommended plots. So if you click on it, it will basically generate the code and the plots for you. Make sure that you do not use it, all right? If even better, just disable it, if you know how to. Okay. Man me. Yeah. Well, at least it's showing on my end. Okay, so if it's showing on your end and you use it, and then TAs or me or someone spot it and let me know, then you're in trouble, because I won't be lenient this time. All right? I mean every word that I said. Oh, ไม่เจอ VS Code also has the autopilot features, doesn't it? No? Okay, then you're good. If there is one, then you're in trouble. All right. Okay, that's it for the announcement and also the seating chart. Let us take a look at it. So I have put it on, I think, yesterday, right? So we have 10 rows in total, and we have 5 columns here. The TA already put the number on, on the table in the leftmost and rightmost column. So if you don't know which row is at, then you have the indicator. All right, so you just have to know where you sit. The number here is basically the ID here. So check out your ID, your name, and which ID, and then locate yourself accordingly. All right? I will finish the lecture a little bit early. The latest would be at 3 p.m. so that you have enough time to take a deep breath and prepare yourself for the exam. Okay? The exam will start at 3:15 sharp on time. Okay? And we will finish at 4:15. Did I say 13? Sorry. We will start at 3:15, 3:15, and it will end at 4:15 p.m. Okay? But if you finish sooner, then that's cool. That's fine too. But today, you need to manage your time really well, okay? Because I strictly enforce this. I will not accept any late submission today, even by a minute. Last time, there are a few people submitted late by, I don't know, a few minutes. Okay, this time around, like you know all the drills, like you have been through it before. So this is, the same thing all over again, like deja vu, okay? So make sure that you do not make a mistake, okay? Yeah. Alrighty. All right. So here's our journey so far. Over there, can you like quiet down a bit? Yeah, it's kind of loud. Okay. So here's our journey so far. Okay. Last week we learned, introduction to classification. I know that it's quite intense, especially for those who has no idea about machine learning or classification. It would be like a probably like foreign information. So and I was also kind of rushing. So I think towards the end it might be a little bit too much for you. Information overloaded. So today I will give a review before we jump right into the parameter tuning. Okay. Here's the outline. As I said, we will do a recap, and then I will introduce you to model parameters and the difference between learnable parameters versus hyperparameters. And I will show you some examples and tell you why it's important, okay? If it's not important, we don't even have to study about it today, okay? And I will also show you different methods of hyperparameter tuning, the ones that is manual and the ones that are more automatic, okay? And some challenges, and that's it. Hopefully we can go through all of these. If not, in the worst case, if we cannot manage to go through everything here, we will kind of shift some topic to next week instead, okay? All right, well, the last time, remember this? Do you remember this? Here's what I asked you to do for, actually it was the lab, right? So see if you get something that's looking like this. Do you recall your answers? So everyone got these numbers correctly? Yeah? Okay. It's well, if you follow all the formulas and do the computation right through coding, if your code is correct, I don't think you will run into trouble. Okay. So that's about it. But I think at this point, some of you who got the answers right probably still like kind of not entirely understanding decision tree classifier, right? So we'll talk about it again today, all right? So if you don't understand, this is the second time around, like your second chance, so pay attention, okay? So decision tree, as we know, it's a method for classification. And here's like the example that we had last time, okay? So we have like, our data have different attributes, and our goal is we want to know if a certain person will buy a computer or not, given these information. So those information include the age, well, you could sit anywhere for now. Those people that just came in, you can sit anywhere for now. ฟังอยู่ปะเนี่ย คนที่เพิ่งเข้ามาใหม่ ตอนนี้นั่งไหนก็ได้นะคะ Okay, so given these information like age and income and whether you are a student or not and the credit rating, our goal is we want to know if that certain person with certain attributes will buy a computer or not. Okay, so it might not like mean a lot to you, but imagine that you're like a company that sells computer. You have like a large number of customers coming in every day. You would want to like have like a certain strategy, okay, so that you could plan your promotion, or you could plan like a campaign or stuff like that accordingly based on all this information, okay? Because you know beforehand that if a person comes in with a quality like this, then the tendency is no, that person won't buy computer, so you wouldn't want to waste time on trying to pursue this person. But if another person come in with a quality like this, like this, okay, you would want to try to come up with like some campaign or some perks for that person to like convince or persuade him or her to buy a computer, because the chance is higher. All right. So from everything that I said, this is our goal. We want to know if given the records of data like this, we want to know if that person will buy a computer or don't or won't buy a computer. All right? Hello. Hello, okay. All right, so the method that I showed you last week, the decision tree, basically it's a set of rules, okay, or a set of patterns basically. So those set of rules will kind of capture different scenario, okay? Like let's say this node, this very node represent the age information, okay? So if the age is some number, you want to know which route it would go for, okay? And the route is basically the condition, okay? So if this condition is met, then it keeps going on to check this condition and then check these conditions all the way until it hits the leaf node, okay? And those leaf node are, you know, whether the person is buying a computer or not. All right, is this part, up to this point, is it still clear to you? Anyone like do not understand? Mime. If it's clear to you, can you like at least like raise your hand so that I know? All right, okay. แล้วตรงนั้นที่ไม่ยกคืออะไร? And those who do not do anything, what does that mean? Like, but you're with me, right? Like you're here, right? All right. So this is this page I copied over from last week. Okay, nothing new. Just want to emphasize the key elements of decision tree one more time. Okay, so the first key point is the word tree induction. So tree induction means training process. Tree induction, training, constructing tree is basically like same thing, like same category, okay? So we do this process to construct, to create the tree or our classifier, all right? And what do we have to be concerned about? Well, we have to be concerned about the best split because we wanna split based on the node that would give like the most in like the gist information. Okay, we don't want to like just keep splitting and right at the end it means nothing. Okay, and we also care about the node impurity. Okay, so node impurity here is the reason why we calculated the entropy, because entropy will determine how impure or how pure the node is. Okay, and last is the information gain. Okay, so these are like all that we dealt with last week. Also the homework, okay? All right, next. So I'm going to like review the entire process one more time, but not in so much detail, more like an overview. So if you do not understand last time and the homework, this is your chance, okay? Well, first, to construct a tree, we need to have root, first of all, because without the root, you can't really have the leaf node, nothing, okay? So we will construct the tree. We want to find out which node, which information here should be the root node, okay? So you can neglect this one because this is the class that we want to predict. All we care are these four. We want to determine which one should be the root here. Okay, so we have age, we have income, students, and credit rating. So among the age attributes, there are three main groups in the age. Okay, so those are less than or equal to 30. That's one. And there is 31 to 40, and another group is more than 40. That's all. Okay, and for income, we have three groups. For student, we have two, either the person is a student or not a student, so just yes and no. And for credit rating, we only have fair and excellent. Okay, so that looks good. So the next step, we can't really just randomly pick anything to be the root, because that won't be efficient. So we want to pick the one that that is the most pure here, that will give us the highest gain, most informative here. All right. So among the age, when we pick this, you can kind of ignore the rest for now and check out the class here. Okay. So among the age, we want to find out in this group less than or equal to 30, how many yeses are there and how many no's are there. Okay, so I actually created this according to really according to the number of yes and no here. So there is 2 yeses and 3 no's. All right, and for 31 to 40, all of them are yes. Okay, and for the last group, more than 40, there are 2 yeses. Or is it 2 no's? มันสลับกันปะ? So are there 2 reds and 3 greens? Is that the case? ไม่เป็นไร That's fine. Okay. So you could see that among this group, the information is kind of mixed up between yeses and no's. Okay, and that's the same scenario for more than 40. Okay, so based on this information, we went ahead and then calculate the purity, okay, informativeness of each group. Okay, so so these are. Okay, so using the formulas that I showed last week, we do the same for all attributes here. So we do the calculation for age, for income, student, and credit rating, and that left us with this as a result. So this is the gain for age, income, student, and credit rating. So it's obvious to us that this one gives the highest gain. Okay, so that's why we choose age to be the root node. Okay, that's the first step. We need to have the root node. So find the one that's most informative using entropy and information gain, and so that's where we are. So now this is a root, and I split that into 3. All right, so what's next? Next is we have to determine whether we should split further or this is it. Okay, so earlier, as you could see, this information is still a mixture between yes and no. This is also a mixture, but this one is done, pretty much done. You can determine that whoever goes down this path will buy a computer for sure. That's already done, okay? So with this, we can just conclude that this is a leaf node, all right? So our leaf node is buy computer is a yes, okay? But this and this is not done yet. So we have to do the same process all over again, recursive, okay? So you have to determine now which information should be the node here, all right? So we have used the age. Now we are left with income, student, and credit rating. So you have to do the calculation, same process all over to determine if income should be here or student should be here or credit rating should be here. All right. Any question up to this point? มีคำถามป่ะคะ? No. All right. So yep. Okay. So at the end, here's the result. Okay, so I've done all the calculation, and it turns out that splitting based on student will should be like the best, will be the best way to go for this wing, okay? And credit rating is the best split note for the right, like the right arm of H, okay? But in the homework, well, the algorithm kind of enforce you to do a binary split, okay? So the result from homework won't look like this. It will just like be binary tree. So if there is any node in your result have like, you know, more than 2 branches, that's wrong. That means, okay, that you did the work, but you did not do it based on the algorithm in the slides, all right? Okay, and another point is that I actually looked over your submissions last night, and I found that you did a good job. Actually, a lot of people did a good job. Okay, some of you guys, I think, got the correct answer, like perfect. But some, I saw that like your tree is a Gini, like you use Gini instead of entropy, and yeah, you use Gini instead of entropy, which is not wrong, okay? Like use the Gini index is also another method instead of using entropy, all right? So that's another way, but I didn't cover that yet, okay? And what else? Some just drew a picture and submitted. Okay, that's kind of weird. Actually, the requirement was asking you to, you know, to code up, okay? If you do not get the correct result, that's fine. I just want you to like take time to look at the algorithm, try to implement it by yourself, because practice is like the best way for you to really understand the entire process, okay? By listening, like passive listening like this won't do anything. If you do not review, if you do not listen, that's even worse. And if you do not like really get your hands dirty, right? Okay. Right, the last page before I talk about model parameter, some interesting points. So do you notice that like when you created the tree in the homework, the more you kind of branch out, the more level you go down, the less impure the node becomes? Do you notice that at all? สังเกตไหม? What I mean is, say if you're at this level, and then ยังไงดี? Okay, so let's say that we're just now focusing on this node, okay? And we don't care about the rest yet. Like just cut this out. If you try to kind of visualize this, okay, and I will need to use, let me see, I'll try to use different colors here. All right, so let's start with this node and we'll ignore the rest for now, like ignore, okay. And let's say this data, we only have like 2 classes, just yes and no, where yes is gonna be a red dot and no is gonna be, yes is a green dot and no is a red dot, okay? If we plot it out, you will see that those that meet this condition will be quite a bit of reds, okay? And also quite a bit of no's, like this. And that's the same situation for this branch as well, and also this branch and this branch. ต้องวาดให้หมดนะคะ All right, I'll do all the drawing so that it's obvious to everyone. Okay, right, so so that's where we are at like the very first level, okay? But as we keep you know, going down, we keep branching out, keep branching out. Over here, there'll be like less mixture of both classes. Like this one, there will be still mixture of greens and reds. ทำไมมันเหมือนกันเลย? But my point is, once you reach this level, which is already the leaf node, it will be like all greens or all reds. Okay. Boop, boop. I don't do a good job at drawing. Okay, there are more reds here. Okay, and a little bit of green. But when you compare to the level above it, any question? Okay, so the mixture is like more severe over here compared to the lower levels. Okay, so okay, so the more we go down the tree, the less impure each node will become. All right, this is one important point here. And second important point is that we created the tree with goal so that our tree will be general enough. Okay, general here, I mean that your tree will be, you can apply your tree to any unseen data in the future. Okay, so so far the data that we use, like this data, okay, this data that we use when we create a tree, we're basically do the training process. Okay, and then we'll do the testing and everything. But then in the future, if you have more unseen data, you would want still to use your tree for any unseen data. Okay, so you don't want to like create a tree to use for like only one time. All right, so if the tree that you created is way too like only work with a specific data like this one and doesn't work with like any unseen data, then that's like a waste of time. Okay, waste of time here, I mean that you can only use it for one time, that's all. Did I confuse you? No? Okay. So in terms of a graph, okay, the generalization could be, it's better to look at this visualization. All right. So if the model or if your tree has like a high generalization, then it would look like this. So take a look here. You could see that there are different data points here. Okay, and there are two main classes. So one class is like circle. So these are one class, like class yes. Okay, and there another class that's across like this. So this is like a class no. Okay, so when you actually like visualize all the data points like plot together in a 2D format, it will like kind of like mess. Like it's looking like a mess, but you can see that your classifier is this line, and it does a good job of trying to separate between two classes here. Although there is like some crossover here, but that's not a lot. Okay, so I think this one is good. This looks like a good fit. Okay, but another scenario is when your classifier is only fixed to a certain data. Okay, look at it. It's like trying to make things perfect by avoiding all the cross and only like it does a perfect separation between two classes, which looks good. It's probably giving you 100% accuracy. But if I give you any new like unseen data in the future, and it's not in this pattern, then your classifier, your tree won't work. Okay, so if the data has like some crossover here, then your tree will just think that this is a circle. Okay, and that's not good. All right, any question up to this point before we move on to a new topic? Like this is like a good time to ask now. Because if you're lost here, then you're gonna be lost more. ถ้าไม่ถามตอนนี้เดี๋ยวหลุดยาวนะคะ Or did I lose you? No? Okay, cool. Okay. All right. All right, we have 1 hour left. We'll talk about model parameters. จริงเหรอไม่มีใครมีคำถามเลยเหรอ Like everyone understood decision tree like perfect. It's kind of impressive. I thought that you will have a lot of trouble with decision tree because last time was rushing. Okay. So well, right, model parameter. So first of all, let's take a look. What is model parameter? Okay, so in layman terms, or like to make it like really easy to understand, it's like a coefficient. Is it easy to understand? It's a coefficient or weights that's learned by machine learning algorithm throughout the training process. Okay. I don't think this is like that easy to understand, but okay, keep listening, right? So these parameters also define your model, okay? And it used to make prediction or classify new data points, and most importantly, the parameters could be adjusted along the training process to make sure that the predicted output and the actual output are, you know, kind of less different, okay, as much as possible, right? So I have to reuse this figure one more time. So as mentioned earlier, this is basically your classifier, okay? So to get like the lines like this, if you think about this as like mathematical, in a mathematical terms, okay? So when you define the lines, you need to have like a function. You need to have like coefficient and everything. Even easier example, what is the function for a straight line? Can anyone tell me? Yeah. Like just a simple straight line. What is it? It's a middle school knowledge. Y, okay, I heard Y. Equals mx plus c. Okay, what is m? What, m is a slope, and what is c? Both of this, m and c, they're coefficient, both of them. What is c? I think you know in Thai, but what is it in English? Huh? Offset? There's like a more specific term for c. Y-intercept, yes. จุดตัดแกน y นะคะ Yep, so this and this is a coefficient. So, อะไรนะ Yeah, it's an intercept. That's right. Okay, so that's like the same idea. This line here, you can also represent that in like some sort of function as well. And you want to make sure that it does a good job at separating between two classes, okay? So those coefficient that comes with this function or this equation, throughout the machine learning process, it will be updated to make sure that it does like a good job at separating between the two classes, okay? It won't show up like this for the first time around, okay? Like throughout the training, it will keep moving, like wiggling here and there to make sure that at the end, you could achieve the highest accuracy, right? That's like the general idea of model parameters. Okay, so coefficients and weights that are learned by the algorithm during the training process okay? And it defines the structure, or it defines how the classifier would look like, okay? And you use that to make a prediction, or use that to separate between two classes, okay? And later on, you can do the classification based on that separation, okay? And it could be adjusted to minimize the difference between the predicted and actual values, right? So there are two main types of model parameters. One is learnable parameters, and another one is hyperparameters, okay? But hyperparameters is, well, throughout the training, it could also be changed as well. But anyways, what is learnable parameters? So this one, these are parameters that are, you want to optimize the values throughout the training process, okay? You could use like some kind of optimization techniques. If this sounds like, I don't know, some terms that are too difficult for you, that's fine, okay? But in the future, if you will study the machine learning or even optimization, you will see more and more of this, okay? And okay, learnable parameters will be adjusted to minimize the loss, okay, to minimize the error, okay? So the example of learnable parameters would include the coefficients in linear regression, right? And weights in neural network. If it doesn't click for you now, that's fine, okay? Just for your information, okay? And another kind of parameter is hyperparameters, okay? We will actually focus on this today, right? So hyperparameters, these parameters will be set, okay, by user before the training process, okay? And you can like have like different techniques to choose hyperparameters to make sure that your model could do like a good job at classifying things, okay? An example would, in neural network, examples are like learning rate, okay? Well, in decision tree, the example would be like depth of your decision tree, depth or number of levels in your decision tree, okay? Or number of hidden layers in a neural network, right? Let's see more example. I make it like even more clear here. Well, I just chose some example here, but I won't go through the detail, okay? Since we don't know the two here, but at least we know the ones from decision tree, okay? When you implemented the algorithm, I believe that you haven't really cared about these yet, okay? But in your algorithm, you can actually like define these values so that you can like kind of set it before you run your algorithm, okay? So for algorithm, for decision tree algorithm, the hyperparameters include max depth of the tree, or number of levels of the tree, or minimum number of sample splits, okay? Like how many samples that you could split in, like in each node, okay? Like the minimum number of splits that you want, or a minimum number of samples at the leaf node. All right, and maximum number of features, how many features that you would want to consider to create a tree, and also the criteria. Criteria here it would include like if you use entropy and information gain, or do you use Gini index instead, okay? Because like those are like totally different functions, okay? If in the homework, if you use entropy, it will result in one tree, like one root. The root will be different. If you use the Gini index, the root will be a different attribute. So the final result is like completely different tree, okay? So you need to use, specify the criteria wisely, okay? And also the splitter. Okay. This is just like more information from this page. Okay, just in case you're interested, I give more detail here. What is minimum number of sample splits? Okay, you actually can read this yourself, right? Well, let's see. Is there anything more important here? Splitter. Okay, so when you do the split at each node, do you do it like randomly, or you split based on like the best split results that you computed? Okay, so those sort of things, right? Now we know what hyperparameters are. We know what learnable parameters are. Now we would want to know why do we even need to tune it. Okay, I kind of said earlier that we need to tune so that just to make sure that our classifier could do like a good job at separating between classes. Okay, so that's one thing, but we have other reasons as well. Okay, so we also tune to make sure that our classifier won't overfit. Okay, I kind of say that right here. So this scenario, when your classifier tries to, perfect the separation, okay, this right here is pretty much overfitting. Okay, so overfits mean it fits over. It fits too perfectly. Okay, it doesn't. It probably doesn't work with any new data introduced to it later on. Okay, so this case is not what we want. Okay, this is actually what we want to avoid. Okay, so this is one reason. What else? We tune to make sure that our classifier or our model is robust. Okay, so if say in the future your data have more variations, or if there's any change in the environment, your model is still like working just fine. Okay, less sensitive to those changes. Okay, and we also tune the parameter to reduce the cost. Okay, so if you can find like the set of good hyperparameters, you will save time and also the resources while you can still like achieve the good performance. Okay, if say you do not set the depth of the tree, you set it like really high, then first of all that would lead to overfitting problem, and second, it will make the computation time really worse because your tree will like probably run for a very long time given a large amount of data. Okay, and by that you will also waste your resources unnecessarily as well. Right. So just the picture is not crisp, but I'm trying my best to find the best quality, but this is like the best I could find. So this is example of overfitting. So you could see that none of the yellows are in the blues area. Okay, but it's too perfect. Okay, and the right fit is, you could see like some yellows are in blue, but for the most part, it does like a good job at separating between yellows and blues, right? Underfitting is the opposite of overfitting. It means that it could not like do a good separation at all, right? So yeah, regression is similar to classification. The main difference is that your data, your output will be continuous value instead of in classes or in categories. Okay, so but the idea is the same. You could see that this one is like trying to, the lines here is trying to kind of cut through all the dots as many points as possible. Okay, which is not possible in real world. It's nah. This doesn't really represent a good classifier at all. And this line kind of pass through as many dots as possible, but it doesn't really like touch those dots. Okay, so at least it's close. Like the distance is kind of close, all right? And this one, this is like way too far. This is way too far. So the further away the dot is from the line is the more error. Okay. Right. Any question up to this point? มีคำถามไหมคะไม่มี right. Right. Okay. So we know the what part. We know the why part. And now here comes the how part. So how to do the tuning. Okay, so the hyperparameter tuning part is actually very time consuming, and based on my experience, when I work with the machine learning, this is the part that takes the most time. for me to find like the best set to run like the model and then to get the result. All right. But now there are like more tools. Like before, say in like the past 10 years, there is like no automated tool. So you have to like kind of write the code to do all the findings or even like trial and error by yourself. So that's like really long time. And that doesn't even guarantee if it will lead to like the optimum good result, okay? So we'll go through it one by one, okay? So we have the manual method. So manual means that you will need to, it will be good if you have some domain knowledge, so you know which value that you should adjust, okay? So which value that you should focus on, okay? And so you need to have some domain knowledge, but the cons part, the disadvantage is that it's really time consuming and not efficient, okay? Have you guys heard of the term monkey testing at this point? Okay, who else have heard of the term monkey testing? Can I see some hands? Okay, one more hand. You guys, like everyone else, have not heard of monkey testing? No? Okay, so monkey testing means it's like testing like a monkey. So it's like pure 100% random, like a monkey. Like you bring the monkey on the table and let it do the testing, just like that, like with no knowledge whatsoever, okay? So that would lead, so you could see here that it's not efficient at all, because whatever values that you would want to try, you don't even know if it will lead you to the good results, okay? And like, let's say you have 1,000, or not, I think that's too much. Like, let's say you have about 250 parameters. Do you know which one that you need to change? Okay. I think that's like finding a needle in a haystack, right? So you don't even know where to start, right? So this is not encouraged, okay? But believe it or not, when you get to the 4th year, some are still using this. Although like you've learned everything, like all the process, but once you get to the 4th year, what is it? Senior. I still saw some groups that using the manual process. Okay, so do not, please do not. Okay, it's not efficient, right? Another method is grid search. Okay, so grid search. So you guys know what grid is? What is grid? Is that an answer? Is that even an answer? It's quite loud. What is grid search? That's a question. What is grid? Okay, what is grid? Like a table? Okay, so it's looking like this, like grid, right? Like a cutting, intersection, yada yada. Okay, yep. So grid actually looks like this. So that's correct. That's correct. Okay. So with grid search, basically you will do exhaustive search. Okay, over the entire hyperparameter space. What I mean by that is I need to give you an example so that it's clear. Okay. So let's use the parameters of decision tree. So in decision tree, as I introduced to you earlier, we have max depth, we have min sample split, min samples leave, max features, criterion, and splitter. Okay, so for each one, let's break it down. What are the values for each hyperparameter? So for max depth, let's say that possible values that I would want to try are set of 2, 3, and 4. All right, so that's just one hyperparameter. Right. For min sample split, I have 2, 3, 4, 5, okay, and so on and so forth. So if I want to try all the combinations here, for example, if I set the max depth to 2, and then I want to try min sample split to 2 as well, and this, and entropy, and then the best splitter. So that's just one case, okay? So that's the first case. The second case would be when I still set the max depth, fix it to 2, but then I change the max samples split to 3, and then everything else is the same. So that's the second case. So can you tell me how many combinations of, of these values if I want to try everything? 1,200? That's it? Really? 3 times 4 times 5 times 5 times 2 times 2. Oh, that equates to this one exactly? Oh, okay. I believe you. So do you think, let's say if each case lasts you for 2 hours per run, that's gonna be 1,200 times 2 hours. That's like how many hours that you have to do to complete all your experiment. Okay, but in reality, these days when the model is like super large, okay, like we're talking about the machine learning model these days. Some takes really short, but if your data is large and say your problem is really complex, it could take up to weeks. Okay, so I think one notable work at Google, when they try to generate a certain thing, which well, I can tell you the name, but then it's gonna be it's gonna be confusing. But so let's say one product of Google, to get that, they take the training time was taking at least 3 weeks. Okay, so in the worst case, let's say one case here takes 3 weeks. So 3 weeks times 1,200. Do you think is that kind of painful to hear? The final product, you can forget about it because it's never going to happen. Your competitor would launch the project before you if you're taking that long time. All right. So grid search, although it does exhaustive search, it tries everything. It sounds like a good thing to do, but in reality, that's just not efficient at all, right? So another approach that's better than grid search is called random search. All right. So if we compare the grid search and random search here, grid search will try every, possibility, okay, every combination. But random search, you can actually randomly pick, the case from here. You can set, okay, I want to do a randomly pick for only 70% of all the cases. So at least that saves you time. You can ignore those 30% while the hyperparameter settings that you tried could still lead you to the good result. Right? You get the idea here? Pocket na? All right. Okay, and so this is completely manual, okay? This method is completely manual. You have to do all the coding by yourself and also making a decision by yourself as well. This one, the machine will do more of the job. All you will need to do is just writing up the code and wait, okay? This one, the same situation, write up the code and wait, okay? Maybe faster. But the good news is that now there are more libraries that have been launched so that you could just call those libraries and it will do the job for you. So good for you, okay? I didn't really have this kind of thing when I was in the grad school. So the first one is a Scikit Optimize, okay? And HyperOpt, I think I've used this one. I also used another one called, I'll just share the name with you. Not sure if it's obsolete already, but the name is Hyperas. Okay, there's HyperOpt, Hyperas, and I think this one is new, Optuna. Okay, so the idea is that you throw all the list of hyperparameters that you would want to try out, throw it, and let it do the job for you. So the idea would look like this. You give the set of hyperparameters, and then it will do all the combinations, and then run all of that and give you the score. And then, you know, at the end, you would just like take a look which one give you the highest score. You don't have to wait and do that by yourself. All right? Okay. And why do I show you this picture? So when it comes to like do the training, well, you would want to achieve the highest accuracy, right? Okay, that's like the goal. You would want your model or your tree or your classifier to be able to like do like precise, like a correct classification for you. So you can imagine, not imagine, this one is a loss graph, right? So when I plot it out, all these values are like the loss value, or you can think of it as like an คิดเป็นอะไรดี loss so let me ask you this. When you create likeไงดีวะมันอธิบายยากเหมือนกันนะเนี่ย All right, I won't talk about the differential equation or anything, although it actually is actually involved, okay? But I won't talk about it, right? But when you create a classifier, your goal is to minimize the loss, okay? Like loss value. Loss by itself is not even like, doesn't even give you a good connotation, okay? So you would wanna minimize the loss as much as possible, right? Okay, like if your model give the high loss, it means that it doesn't do a good job at classifying anything. Okay, if you use it, it will give you like a wrong result. So you would want to get like the lowest loss amount as possible, and that's like right around here. Okay, like this one looks like a low loss. This one is also like low value of loss as well. But if you look closely, the loss over here and here, this one is lower. Yeah, can you spot that? Can you see that it's lower? พอเห็นไหมคะ It's slightly lower. Slightly lower right here. Okay. So you want to make sure that you are not stuck here and think that this is like the best, like where your model is optimized. You don't want to think that, okay, the hyperparameter settings that you got when you are here, you thought that is the best. That's not the case. Like the good ones is actually here. All right. If you will ever take machine learning, you will need, you'll go through this one more time, learning about the gradient descent and everything, and like the loss function. So that'll be a thing for future. But the gist of this page is that with the good hyperparameters, it will tentatively lead you to the global minimum, like the real lowest loss of, you know, all among all the values here. This is the best point, okay? This is the goal, not anywhere here or here or here or here. All right. Boop. Okay. Well, the real challenge of hyperparameter tuning is, as we see earlier, the search space could be large, right? Depending on the number of parameters and also depending on the number of values per parameter, okay? And computational resources as well, because it's taking a lot to run all the cases. Although you random some cases, that's still a lot. Okay, and overfitting could still occur with hyperparameters, so that's a challenge. So you have to also make sure that while you're tuning the hyperparameter, the classifier is not like trying to like perfect the separation. Okay, and if the data is noisy or it contains some incomplete information that could lead to the suboptimal setting that I said earlier. So there are two here that I could see. So one like right over here and one over here. So that's not like the real optimal setting. Okay, so that could be a challenge for like the tuning. อ้าวจบแล้ว Yeah, I thought that this will take a long time. That's why I actually took a few slides out. Okay. Should I continue? ต่อไหมยังได้อีกเรื่องหนึ่ง or you want to start the exam early? Yeah, well, actually we have like about half an hour left. I took out, there's actually one more topic, but on purpose, I took them out. Because last time I ran out of time. So I thought it's going to be the case for this week. But looks like I was wrong. No. No. Or do you want a lab or homework? From what class? This class? Oh, so you have homework from another class. Oh, okay. I won't give you homework today. I don't know if I understood you. Well, are you saying that you have homework from another class, right? And like a lot of questions in your homework for another class. So do you want more homework from this class? That's my... Oh, because you make it sound like I thought that you don't want it, but then now I'm not sure if you actually want more on top of that. Anyways, อยากได้การบ้านเพิ่มไหมคะ Okay. We have about half an hour left. Why not, right? Let me talk about one more thing about the evaluation, because otherwise this topic will be, will be a burden to next time. And then next time it will keep shifting. Do you want that? Because it will be, I think I can finish that in 15 minutes. It's just the evaluation, like how you compute, that's all. Okay? ปิดจอยังไงอะ It's okay. Hello. Faster than you think. All right, that's it. I told you I already prepared for it. Okay, so the last bit of today is gonna be about how to evaluate if your classifier is good or not good. Okay, well, there are three main methods, like three main criteria. Okay, I will call that a criteria. So the first one is accuracy. Okay, so accuracy will determine how correct your classifier or your model is. Okay, So the value would be a ratio between correctly predicted instances versus total number of instances. So instances here is data points, okay? So number of ratio of correctly predicted data rows versus all data points, all records, right? So that's accuracy. This one is straightforward, okay? Recall is telling you how many actual correct or positive instances were correctly predicted, okay? Well, it could still be confusing, but we'll see next page. Next slide will be more helpful, okay? And precision will tell you how many predicted positive instances are actually positive, okay? That's fine. If it doesn't click, we'll see next page, okay? Generally, we will use this, we call it a confusion matrix, okay? So confusion matrix will kind of have like all the cases, okay? So make sure that you have this part. This is like actual value, okay? Actual class, and this part, the top here, is a predicted class, okay? And then we will put in all the possible cases here. So say if the actual class value is a yes, but it's predicted as a no, then you put it right here. ไม่เห็นเนาะ อุ้ย เอาสีไหนดี okay. So if the actual class is a yes, but your model predict as a no, then those will be counted right here, okay? But on the other hand, if the actual is a no, but then your model or your tree predict as a yes, then it will go here, okay? So you do all the cases, you count each case, and then you put it in this confusion matrix, okay? And with all the numbers in this confusion matrix, you then can compute for accuracy, recall, precision, and also the F1 score. We'll see the F1 score in a bit, okay? Let's talk about accuracy one more time. Okay, so accuracy is overall correctness of the model across all data points, okay? So, so the calculation says it's a true positive plus true negative. Oh, by the way, I put TP right here. This one is short for true positive, okay? T is true and false, okay? Like just true and false. T and F is for true and false, right? And P and N are for positive and negative, okay? Okay. Boop, boop. Okay, so accuracy could be calculated through a summation of true positive and true negative. Okay, so those that are correctly predicted, okay? So actual is a yes, also predict as a yes, so this is correct, perfect, okay? And actual is a no, and also predict as a no, so this one is all correct, perfect, okay? So we sum the two values and then divide it by all the numbers here. So that will give you the accuracy value, just like straightforward, just like that, okay? And recall, it tells you how many of the actual positive were correctly predicted by the model. So in terms of the calculation, it is a true positive over true positive plus false negative. So that value is true positive. True positive over true positive plus false negative. So this line. Okay. So how much the model could recall, right? And for precision, that's slightly different, okay? It's still true positive, but the denominator would be true positive plus false positive. Okay, so this column right here. okay? And F1 here, or F measure, F score, okay? Well, if you use only the recall value or precision value, sometimes it's kind of like not entirely correct. It could still like be some bias in it, okay? Let's put it that way. So with the F measure, it does like it concerns, like it cares, take into account both precision and recall and do some weighting to get like the final result, okay? So, well, to compute that, it's 2 precision times recall over the sum of the 2, okay? Yeah. Any question for this page?มีไหมคะ? All right. So in the previous page, I think just by like saying it out loud, like through verbal information only, you probably don't get it yet. So I have, this picture right here to help explain precision and recall. So you could see that precision is basically those that are like correctly predicted, like, this part, the true positive part, over like all the selected element. So all the cases over here. So the ratio of those that are really correct over all the selected element. All right. While the recall would be still true positive part, but then the denominator would be the whole area here, those elements that are relevant. Okay. Generally, I encourage you to try to understand this figure. It's really helpful here. All right. And another thing that I want to talk about is the error. Okay. So I have there are 2 errors here. Okay, so one called false negative and another one called false positive. And I use different shade of red here because the severity level are different. Okay, so type 1 error or false positive is like right here. Type 1 error, false positive means that this guy incorrectly diagnosed this guy that he is pregnant, which is impossible because he's a guy. Okay, so it's wrong, but is it severe? No. Okay, it doesn't lead to any bad consequence. So just an error, that's all. But when it comes to this case, false negative, okay, false negative or type 2 error, okay, they call it a type 2 error. This case, this woman is clearly pregnant, okay, but then the doctor tells her that she's not pregnant. So that's like clearly wrong, like wrong. If it's okay, this is like a joke, but if you think in a real world, if a person is actually having a cancer, okay, and then the doctor says that you're fine, you're normal. So the person doesn't, doesn't get any therapy, doesn't get any treatment, that would lead to quite a bad consequence because of the delay, because, that matters, right? So that's why they call it a type 2 error, okay? All right, we're like done now, like really done, okay? So let's quickly summarize what we have studied today. Okay. So I first introduced you to the model parameters and so why they're important and everything, and there are 2 main types, okay? So ones that are a learnable parameter, so these values, these coefficients or weight will be updated, could be adjusted throughout the training process, okay? The main difference between learnable parameters and hyperparameters are that this one will be, the values will be set beforehand, okay? And examples of hyperparameters and machine learning algorithms are like the ones you can like go back to see those parameters in neural network or the ones we use in decision tree, okay? We have like max depth, max number of features, minimum split and all that, Okay, and we've seen some necessity and the benefits of doing the tuning. Okay, and we also saw different methods to tune hyperparameter, and that includes like the manual settings. Okay, but that one is not good because you need some domain knowledge, and also it's like monkey testing, trial and error, so it's not efficient. So the second method is a grid search, but this one is also too much, too exhaustive, okay? So there we have random search. So this one is better, an improvement of a grid search, okay? But is it still like good? Well, it's better, but it's still taking your time and effort to do it. So these days you could opt for libraries that are out there. I introduced you to 4 of them, but I believe that there are more out there. So you better check that out yourself. Okay, and some challenges like overfitting problem, the resources problem, the time problem. All right, yeah, I think I've covered everything. Any question? Time for asking.